Okay, so the next question that we have is, suppose 3 bulbs are selected at random from a lot. So you select 3 bulbs at random from a lot. Each bulb is tested and classified as defective or non-defective. So you have basically defective and non-defective. So these 3 bulbs are, I suppose these 3 bulbs are tested and classified as defective or non-defective. Now write the sample space of this experiment. So it's basically, you have the sample space could be, for example, bulb 1, it's either defective, or you can say that bulb 1 could be non-defective. Then bulb 2 is defective, or bulb 2 is non-defective. And then bulb 3 is defective, or bulb 3 is non-defective. And that's, I suppose, the sample space for this experiment. So alright, since it seems that it's actually been dead. It seems that, well, it seems that I didn't understand the question right. So the question is basically, suppose 3 bulbs are selected at random from a lot. Each bulb is tested and classified as defective or non-defective. Meaning that all of the bulbs that you have over here, all of these bulbs are actually have been tested. These all have actually been tested and classified as defective or non-defective. So now from all of these bulbs, let's say that you have a lot, basically, meaning many bulbs over here all together, and then some of them are defective, some of them are non-defective. And at random you select 3 bulbs. So what you want to know is basically all the different possible ways that, for example, you could get, for example, 3 non-defective bulbs, you could get 3 defective bulbs, you could get, for example, and of course it seems that the order is important, meaning that for example, I got 3 ends over here. It seems that this represents the first bulb, this one represents the second bulb, and this one represents the third bulb, right? So what that means is that now to basically find the sample space for this experiment, I'm trying to find a way to do it. Okay, so now to solve this problem, basically to solve any sort of problem, of course you need to think about the problem, and of course you know that to think about anything, you need to have some way to think about it, otherwise you will not be able to think about it. And of course mathematics is just, you can say that it's a bunch of ways that we have basically come up with to think about different things in different situations. Now, for example, to solve this problem, what you can do is that I can think of this problem as the same problem that we solved before. That we said that, for example, we tossed the coin 3 times, meaning that in the first time we got basically heads and tails. The second time we got heads and tails, or tails, and the third time we got either heads or tails. And then we somehow came up with a way to basically put these together to basically find the sample space for that experiment. So now we can do the same thing. Here, every time that you pick a ball, you have either defective or non-defective. So we have called them D and N. So instead of H, you can just simply write D and N. So that means that the first time that you pick a ball, you got either D or N. The second time you got either D or N. And the third time you get either D or N. So again, it's the same problem, and you can use the same way of solving the problem. You can basically use the same method that you used in order to solve the problem that you solved before, to solve this problem. Meaning that, well, I could, for example, take these two balls together and write basically all the different possibilities for these two, meaning that I can write D and D, I can write D and N, I can write basically N and D, and I can write N and N. And I can write N and N. And then basically what I have basically left here is another D and N, which is related to the third lamp, or to the third ball. So now you need to take this with basically each of these choices. You can take them with either D or N. So this goes with D or N, and then this goes with again D or N. The other one goes with again D or N, and the other one goes with again D or N. And that's basically how you solve this problem. So then you can write, for this situation, you can write basically S is equal to, for example, DDD or DDN, DDD, and then you have basically, this is 4 times 2 is supposed to have 8 basically elements here. DDD or DDN, and then you have DND, DNN, DND, and DNN, and DNN, and then you have NDD, NDN, NDD, you have NDN, you have NDN, you have NND, NNN, NND, and NNN. That's basically all the different members of this basically what do you call it? Your S, your I've forgotten the name right now. So you get basically 6. So DDD, you got DDD, you got DDN, you get basically DND, you get NDD, you get DNN, you get DNN, you get NDN, you get NDN, you get NND, and you get NNN. That's exactly the correct answer here. Okay, so the next question that we have is okay, so now the next question, I have to basically keep going back and forth in this video. So if you see that the video jumps to some, seems to be jumping to some other point, that's normal, because sometimes I solve a problem, it turns out to be not exactly the right answer, so I have to go back and do it again. So the question is, a coin is tossed. So you have basically a coin is tossed. A coin is tossed. If the outcome is head, basically if heads, then a dice is thrown. Then a dice is thrown. Then a dice is thrown. If the dice shows up an even number, the dice is thrown again. It's thrown again. So now you want to write a sample space for this experiment. So in these cases, I find it much more convenient to draw some sort of diagram for what happens, because I usually get confused in such situations. So when you toss a coin, you either get heads or tails. Now it says that basically if heads comes up, then a dice is thrown. So if you throw a dice, basically you get either 1, 2, 3, 4, 5, and 6. And then if an even number shows up on the dice, meaning 2, 4, or 6, then what happens is that the dice is thrown again, meaning that you will get again either 1, 2, 3, 4, 5, or 6. So that's basically what happens here. Now to write the sample space for this, that's basically how you write it based on the way that it's been written in the book, and I think that's, well, standard enough. There might be other ways of writing this as well, but since we are following this book, we have to basically, well, follow the book, because well, of course, everything in the book and in all of the books, basically in all the series, fit together, so you have no problem with that. So then basically, so the sample space for this experiment would be S is equal to, so you get either a tails, which after which nothing happens, so that's one element here, or you get basically a heads, and then these numbers basically come up on the dice, so you get H1, H3, and H5 here, after which nothing happens. H1, you have H3 and H5, and then you have these three numbers as well, after which these numbers will occur as well. So you have H21, for example, H22, H23, and so on and so forth. So you have, for example, H21, you have H22, you have H23, and so on and so forth, all the way up to H26. Then again, you have H41, for example. You have H41, you have H42, you have H43, and so on and so forth, all the way up to H46. And then you have H61, you have H62, you have H63, and all the way up to H66. And that's the sample space for this experiment. Of course, over here you can fill these with the rest of these values, but I suppose that's not a problem. So question number 13 is the number 1, 2, 3, 4 are written separately on 4 slips of paper. So you have 1, 2, 3, and 4 written on 4 slips of paper separately. The slips are put in a box and mixed thoroughly. A person draws 2 slips from a box. So then basically these slips are put in a box and mixed thoroughly. Now a person draws 2 slips from the box, one after the other. So a person draws 2 slips, one after the other. One after the other. Without replacement. Without replacement. So describe the sample space for this experiment. So the person who draws these 2 slips, well, without replacement, one after the other, he could draw, for example, he could draw number 1 and number 2, number 1 and number 3, number 1 and number 4, or 2 and 1, 2 and 3, 2 and 4, 3 and 1, 3, 2, 3, 4, and so on and so forth. So it's not that hard to come up with a sample space here. So it's either he picks the first one and then he picks the second one, or either he picks the first one and the third one, or the first one or the fourth one, right? Or basically what happens is that he picks the second one, so, and then the first one, or the second one and the third one, or the second one and the fourth one, or he picks the third one, so that would be 3, 1. Then you could have 3, 2. Then you could have 3, 4. Or you could pick the fourth one and then the first one, the fourth one and the second one, and the fourth one and the third one. So that's basically what could happen, I suppose. Number 13. We have 1, 2, 3. Okay, that's exactly the right answer. Number 14 is an experiment consists of rolling a dice and then tossing a coin once if the number on the dice is even. Okay, so if the number on the dice is odd, then the coin is tossed twice. Write the sample space for this experiment. So the experiment is basically like this. You roll a dice. And tossing a coin once if the number on the dice is even. So if you get an even number, then what happens is that you toss a coin once. you toss a coin once. If it's an odd number, if the number on the dice is odd, the coin is tossed twice. Then toss a coin twice. Okay, so that's basically the experiment. So that means that when you roll the dice, you get either 1 or 2 or 3 or 4 or 5 or 6. Now if it's an even number, then basically you toss a coin once. If you toss a coin once, you will get either tails or heads. That's basically what happens here. If the number is odd, meaning 1, 3 or, oh, this is wrong, I'm sorry. This is supposed to be 6. This is supposed to be 6. So if the number is odd, then what happens is that then you toss a coin twice, meaning that you get basically either tails or heads here, and then again basically the second time what happens is that after the tails you could get either tails or heads, or after the heads you could get tails or heads. That's tossing a coin twice. So okay, so now we need to write this namespace for this experiment. So basically, starting from the top, you have basically 1 and 3 and 5 comes over here, and over here we have these. First of all, we need to simplify this situation here, otherwise we would get into trouble. So this will give me either head, tails, head. This gives me this part over here gives me tails, heads, or heads, tails, or heads. So this is what I could get over here, any of these 4, right? And so either 1 or 3 or 5 can have any of these basically successors. That means that you could have 1, then tails. You could have 2. You could have 1 tails, heads, 1 tails, heads. You could have 1 heads, tails, 1 heads, tails. You could have 1 heads, you could have 1 heads, and then the same thing can happen in the case of 3 and 5 as well, meaning that you could have 3 and tails, for example, 3 tails, heads. You could have 3 heads, tails. You could have 3 heads, and you could have 5, again the same thing here. So 5 tails, 5 tails, heads, 5 heads, tails, and 5 heads. So that's a 3 over here. And then over here, in the case of 2, 4, and 6, you could get either tails or heads. So you could have 2 tails, 2 heads, 2 tails, 2 heads, or you could get 4 tails, 4 tails, 4 heads, or you could get 6 tails, 6 tails, and 6 heads. That's basically your sample space here. So number 14 is so we have 1 head. In total we have how many? Number 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 18. So that's 4 times 4 is equal to 16. I think we have forgotten something. This is 4, this is 4, this is 4. No, this is correct. I mean, most probably it's correct. The number is correct. So, and we haven't made any mistakes there. Okay. So question number 15. We have question number 15. Okay, so the next question is, a coin is tossed. If it shows a tail, we draw a ball from a box which contains 2 red and 3 black balls. If it shows heads, we throw dice. Find the sample space for this experiment. So a coin is tossed, so basically you get tails or heads for the coin. And if you get tails, you draw a ball from a box which contains 2 red balls and 3 black balls. So you got 2 red balls, 2 red plus 3 black balls. So that's basically what you do if you get tails. And if it shows head, we throw a dice. If you get heads, you throw a dice. You get either 1, 2, 3, 4, 5, or 6. So that's basically what happens here. So that means that you get basically tails. The sample space for this experiment is tails. For example, R1, red 1, the first red ball, or you get, for example, tails and R2, for example, you get basically tails B1, B2, B3. So you get tails B1, you get tails and B2, you get tails and B3. You get tails and B3. And then you have heads with either 1, you have heads with either with 2, you have heads with 3, you have heads with 4, you have heads with 5, or heads and then 6. So I suppose that's the answer here, number 15. So you get tails R1, R2, okay, B1, B2, B3, H1, H2, H3, okay. Of course, they have written this, for example, this way, meaning that they have omitted the commas and then they have written it as, for example, T R of 1, or T R of 2, or T, for example, B of 1, or T B of 2. Of course, this color is not good. Or T, for example, B of 3, and then, for example, this one over here, they have written it as H1. So these are subscript, and these are actual numbers, no subscript. So that's basically they have written that. Question number 16 is a dice is thrown repeatedly until a 6 comes up. What's the sample space for this experiment? So a dice is thrown repeatedly until a 6 comes up. Repeatedly until the 6 comes up. When you say dice is thrown repeatedly until the 6 comes up, that means that you could actually throw the dice any number of times before 6 comes up. So how do you let me take a look at the answer. Okay, so there is a question number 16 here as well. I'm not going to read the question to you because the question doesn't make any sense to me. I have been thinking about it. I mean, the question is not wrong or anything, but the answer that has been provided here is, it doesn't make any sense to me. So I'm just going to forget it. And so the next thing that we will talk about is events. So I'll see you in the next video.